Hi guys, so you pretty much know the drill by now. The instructions for your homework are on the screen. It's the same homework assignment as the last couple nights. Obviously it's different problems. If you want to just double check at the top of your page, you should be looking at the questions that say Free Response Strategies Part 1. And this is the last part of that packet. They're not free response, they're multiple choice. Let's get started. Okay, so question 1 was just a straightforward quotient rule, and I am going to just remember that it's low d high minus high d low. There's my low function, there's my high function. And in fact, when you plug in the quotient rule, you can just see the answer right there. It is E. Another way you could do this is you could go through and identify what's wrong with each of the other ones. For example, this one did high D low first instead of low D high, and that's why D is wrong. C is wrong because there are no parentheses squared on the bottom. B is wrong because we're just missing terms. A is wrong because they just took the derivative of the top and the derivative of the bottom, and you are not allowed to do that. So, question 2. First step here is to do implicit differentiation. The reason I know that is because x and y are in the equation on the same side of the expression. So implicit differentiation just means to take the derivative of both sides and to pretend like y is a function. I'll start by taking the easy derivatives here. The derivative of x squared is easy. It's just 2x, and that's technically called a power rule. You just bring the 2 out front and drop the exponent. And then on the other side, the derivative of 8 is 0, and that's the constant derivative rule. And then I'm going to use color coding for the middle two terms. To take the derivative of negative 2xy, I'm going to need to use a product rule. And I see that because I have something times something else. My first part of my product rule is going to be the negative 2x. My second part is going to be y. And so I bring it down and I do u dv plus v du. My preference when I have a negative out front is to pretend like the negative is part of the u function, which is why when I brought the u function down it was negative 2x and the derivative of it was negative 2. You also could have kept the negative in front and after getting the product rule distributed that negative to both terms. Either way, you would end up with the same answer. Now, don't forget, I still have to take the derivative of 3y squared. To save myself some space, I'm going to temporarily just write d dx of 3y squared, and then I'll take the derivative on the next line here. I want to just clean up the front. I recommend using this notation anytime you want to just make sure that you aren't dropping any terms, so I'm not forgetting that I have to take that derivative, but I am also allowed to move on to my next line so that I can start to save some space. So as promised, I brought everything else down, and now you really need to recognize that this is actually a chain rule. Think of it this way. The outside function is 3 times something squared, and the inside function is y. You should see that if I put the inside function in right there, I do get the original function. So to take the derivative of this, well, this is just a power rule. Multiply the 2 in front, and we get 6 times something to the first power, which I don't have to write. And the derivative of y is y prime. To use the chain rule, we're going to come back here and we start taking the derivative of the outside, plug in what's inside, and multiply the derivative of the inside. We're now done taking the derivative implicitly. The next step is I want to gather all my terms with y prime on this side and move everything to the left. From there, I pulled out the common term and I divided, and you've seen this before. If this is confusing to you, go back and watch the implicit differentiation video. And now, when you get to this last step, it's a good idea to look through your answer choices, but you notice, and I notice, that none of them are quite right. This one looks really, really close, except that the signs are backwards on the x and the y. Here the y is negative, here it's positive. I could flip the order. But even if I flip the order of the way I write it, the negative belongs with the x term. So C is really close, but it's really not right. And so the last thing that you can do here is you can actually take out a GCF of 2 on the top and the bottom. And those GCFs cancel, leaving you with y minus x over negative x plus 3y. And that's the same thing as 3y minus x because the signs are the same. The 3y is positive and the negative x is negative. So this expression is the same thing as e. In question number 3, we're going to use the chain rule, and that's because I see a function inside of another function. The outside function is the square root of something, and the inside function is 1 plus the square root of x. Now I need to take the derivative of each of these. But these are not things that are easy to have the derivative right away, so I'm actually going to rewrite each of them using a sneaky exponent. The function square root of something is the same thing as saying the something to the 1/2 power. And to take the derivative of that, we just use the normal power rule, multiply the exponent out front, subtract 1 from the exponent. And actually, this is the derivative, but there's a better way to write this. A negative 1/2 power is the same thing as a square root symbol on the bottom of a fraction. Remember, the negative pulls it down, the 1/2 is why it's a root. Similarly, for the bottom function, 1 plus the square root of x is the same thing as 1 plus x to the 1/2. To take the derivative of this, the derivative of 1 is 0, goes away. And then we just use a power rule, multiply the 1/2, negative 1/2 power, turns into a square root of x on the bottom. So here's the derivative of the inside, here's the derivative of the outside. Let's set up the chain rule. I start with the derivative of the outside, which is 1 over 2 square root of something. Into that space, I plug in the inside function, which is 1 plus the square root of x. And then I multiply the whole thing times the derivative of the inside, which is 1 over 2 root x. And then the rest is just fraction rules. When you multiply these together, 2 times 2 is 4. These two radicals cannot multiply because they don't have the same terms inside. And the correct answer is D, right there. You can just see where it's coming from. Question number 4 is really quick. If you made a mistake, I'm guessing that you picked A. You just picked the leading coefficients. But remember that if the degree is higher on the bottom of the fraction, then actually the whole fraction is going to go to 0. And that's because as x gets really, really, really large, we end up dividing a number by a much larger number. So our answers get very, very close to 0. For question 5, the best thing you could have done to start would be just to annotate a little bit. Figure out what each of these terms are saying. Figure out what your answer is going to look like. So for example, I know that tangent lines have slopes that are the derivative at a point. There's my original function. Here's my point. And I'm looking for the x-intercept of this line. And I know that the x-intercept is a point where y equals 0. It's also known as a 0 or a solution. So I'm going to start by trying to write the equation for this line, and then I'm going to try and find its x-intercept using some sort of strategy. To start the equation, I've got x and y, so I'm going to use point-slope form. But in order to finish point-slope form, I need this slope. So in order to find that, I'm going to take the derivative of the function, which is 3x squared minus 4, just using the power rule. And then I'm going to plug in the x value of 2 to figure out what the numerical derivative at the point is. That number is the slope. I ended up with 8, so there's my slope. And this is the equation of a line. I want to know what the intercept is, the x-intercept, not the y-intercept. So to find the x-intercept, I plug in y equals 0. If you're not sure where that came from, I would recommend on a test that you sketch it out and think about the meaning. I've got some sort of line, it's got a positive 8 slope. I don't really know where its y-intercept is, but it's going to look something like this. The x-intercept right here, think about what that point is. That's the point where y equals 0, and we want to know what its x is going to be. So all I need to do is plug in 0 for y and solve for x. When I do that, you can see the work right here, but I end up with x equals 1, which means that this is the right point. Y value is 0, x equals 1. When I look at number 6, the first thing I think is that normally we solve a limit by plugging in the x value, but we can't do that if we get a 0 denominator. So the next thing I think is, can I use the known limit, which is sine x over x equals 1 when x approaches 0. And the reason I'm thinking that is because I can see that there is some trig. I'm going to show you how I would do the workout. There are a couple of different ways in which you could show your work. So the exact order in which I do it isn't essential. What's essential is that you have the main steps. So the first thing I'm going to do is since I want to think about sines, not tangents, I'm going to switch the format of this to rewrite tangent using a trig identity. And when I do that, I also recognize that tan cubed is the same thing as tangent cubed, so I'm just putting the cubed right there. My next step is going to be to write this out as an even fraction, so I'm going to keep change flip. And at that point, I went ahead and distributed the cubed to the top and the bottom, because my next move is going to be to split them out. I'm going to now rewrite this, and I actually made a mistake here if you see it. This all needs to be a limit, otherwise it would be wrong. My next step is going to put the sines over the x's because I want to head to something that looks like this. And here, if you think about it, I'm now really just working with this part of the expression because I could plug in 0. Cosine of 0 is 1, so this would just be 1 over 1. That's not a problem. I do need to continue to figure out this, and my goal is to have sine of 2x over 2x. So I'm going to split this next out into 3 different signs just so that it's easier for me to see. And now there's that magic trick where you say, I really would like to have a 2 right here on the bottom. So I'm going to multiply this times 2 and times 2. The reason I'm allowed to do that is because 2 over 2 is 1, so I'm not really changing what the expression means. The reason I want to do that is because my next step is going to be to take the 2 as part of the sign and to leave the other 2 at the back. I'm going to do the same thing for each of these terms, in fact. And from there, we end up an expression like this, and now we can evaluate because each of these are defined. The limit as x approaches 0 of this term is 1, and then we have that times 2 because that was the leftover 2 on top. There's another 1, and these are all being multiplied, times the 2 that's left over, times 1, times the 2 that's left over, times 1 because we just plug in. And when you multiply this all out, you get 8. Question 7 starts off as a chain rule because it's fundamentally something inside something else, but then the inside function is going to be a quotient rule. Many of you have started to do chain rule in your head, which is great. It's fine, you should. For these multi-step ones, though, I highly recommend setting it up off to the side. My outside function is something to the 4th power. The derivative of that is 4 times something to the 3rd power. That's just power law. The inside function is a quotient, so I use quotient rule to take the derivative. Double check my math really quickly. Make sure you know where each of these terms comes from. And we'll put it all together. So you take the derivative of the outside, plug in the inside, multiply the derivative of the inside. Looks like this. And then we have an x value, so we just plug in 1. I'm going to do this mentally, but basically just 1's in each of these fractions. What we end up with is 4 times -1. Make sure that you simplify this expression before multiplying it. It turns out to be 13 over 1, which is why the answer was -52. Pause if you need to look at any of this work, otherwise we'll do the last one. Question 8 is a simple chain rule this time. The outside function is 3 to the something, and the inside function is pi times x. The derivative of pi times x is easy because that's just a coefficient and a number, so that's just pi, the coefficient. And then you need to remember the rule for exponential functions. You can remember this based on e to the x because basically you have the same expression that you started with, then you just tag on the ln of 3 anytime your base is not e. If it was e, there would be nothing in front. It would just be the derivative of the e to the x is e to the x. We put it all back together. Start with the derivative of the outside, so we get ln of 3 times 3 to the something. Plug in the inside function, there's 0 pi times x, and multiply the derivative, which is pi. And so now that's where I would look at what I get when I take the derivative, compare it to my answer choices, and it's actually exactly the same as e, just like that. This is the end of the video. Please do make sure if there's questions that you don't understand, listen to the explanation a second time, pause a couple times. I rush through these explanations so that I can make sure that you get everything in. But all the information's there. You just need to pause and think about what I say, each sentence. And then, of course, bring your questions to class tomorrow if you still have questions.